Okay, what I would like to do today is another example, actually two examples, which involve writing rules, which are a more complicated version of a formula that we used in the last 3, 4 weeks. So the first problem that I'm going to be doing is a block, which is traveling along a track. We have done problems like that many, many times. And this block is going to be oscillating back and forth using, a sinusoidal motion. And then once I do that example, I'll come back and do another example where two blocks are racing against each other based on the information that we provide uh, to the code. So here's the first problem. We have a block which is traveling along that path, except that the position as a function of time is given by this expression. Notice that what happens, it travels at the first 2 seconds, it travels at a constant velocity, which is 6 inches over 2, so 3 inches per second, right there, 3 inches per second. And then once it reaches after 2 seconds, it follows a sinusoidal motion like that. So it goes 2 cycles over a 2 second period. That means 1 cycle in 1 second. You can see that 1 cycle in 1 second. And therefore, what we need to do is we have to write the expression for this mathematical function in CATIA. So if you look at the position of the block as a function of time is the 6 inches plus, so a sinusoidal motion with an amplitude of 6 right there, 6 inches times sine of t minus 2s, because that 2 comes from the fact that we have to subtract the time shift basically. So t minus 2, the 2 comes from here, and then it goes 360 degrees in 1 second. In other words, 1 cycle in 1 second. So it goes on for another total duration of 4 seconds, and then from that point it travels again along a constant velocity, which is going to be 14 over, let me see now, 14 over, what is this? This is 14 over, this is 6, okay? So that's a mistake. That should be 14 inch in 6 seconds. This is a mistake. That should be 14 inch divided by 6 seconds. See that? Oh, I'm sorry. No. 14 minus 6. So that's 14 minus 6. So that's going to be a distance of 8 inches in 6 seconds. So this is correct. Okay. It's not 14. It's 14 minus 6, which is 8 in 6 seconds. You can see that. And of course, don't forget to include the time shift. All right. Now, in order to do that, we have to write basically a C program, which doing exactly what I said based on these formulas that I mentioned, and we're going to solve the problem. Okay, so let's go ahead and start with CATIA. Let's make this thing insert a track, insert a new part in there. And let me call this thing the track properties, a track and track. Okay, let's make it. Double click on that. On that vertical plane, I will sketch. Okay, I'll sketch a rectangle like so. This is going to be the track, so the size of it doesn't matter. Exit, and I'm going to add this thing by 14 inches. And the reason I do 14 inches because you can look at total distance that it travels is 14 inches. Okay, so I can make it longer if you want, but now I have to be in part design. So mechanical design, part design, because I want a pad. I'll make it, actually, I'll make it 16 inches. Okay. That's fine. So this is going to be the track. All right. Double click, insert the block, insert a new part. I'll call this thing block. Right click, properties, block, and block. Say okay. Let's make it. Please don't forget to make the appropriate saves so that if things crash, at least you have your stuff all lined up. So on that vertical plane, I will sketch. Yeah, so I'll sketch a rectangle. Exit. I'm going to pad it by 1 inch. Okay. So this is my block. Okay, good. All the way to the top. Let's go to the assembly design, mechanical design, assembly design. We're going to anchor the track. There we are. And then because this is a prismatic joint, we're going to create our constraints. So coincidence between this face and that face, and coincidence between this edge and that edge. There we are. Okay, so that's pretty much it. So now we're going to go to digital mockup, start, digital mockup, DMU kinematics, get the magic wand out, new mechanism, auto create. This is going to be a single prismatic joint. The degree of freedom is 1 to make it move and animate. Basically, we have to make that thing 0. So I'm going to make it length driven, except I want the block to travel in the other direction. So I flip this arrow. Good. Now we have to write basically this code. Okay, so what we're going to do is we have to go to start a knowledgeware, knowledge advisor. There is my reactive feature toolbar. Click on this, which says rule. Rule number 1, there's only one rule here, and this is the date. That's my name, and we say okay. All right, and we are ready to roll. So let's start. Let me see now. So if time is less than 2, it's just 3 inches over 1 second, or 6 over 2. Okay, so if time. Now, if you want to see the stuff related to the mechanism, just click on this thing. Only the stuff related to the mechanism shows up. Double click on that. If time is less than 2 seconds, then we know how the distance works, the length works. So this is equal to 3 inch underscore second. So that's 3 inches per second. Or if you want, you can write it as 6 inches divided by 2 seconds, either way. And then times a variable time. There it is. Okay. And then we go to the next line. If or else, if time is less than. Now let's see now. Here it looks like it's less than 4 seconds. You can see this. Less than 4 seconds. So less than 4 seconds. Okay, the length is going to be equal to, we start at 6 inches to begin with, plus. Now here's what I'm doing. Notice that I have to do 6 inches, the amplitude is 6, and then this thing, okay? So we're going to go here, plus 6 inches times sine. Now, how do I know what the mathematical functions are? Well, you can click on this. I can type a sine here, but if you ever wonder, you go to the math right there, and you can see the sine is right here, right there. Okay, sine. parentheses, t, or time actually, not t. So let me go back here. There we are. Time. Let's make sure we don't have. Okay. Let me see now. Sine of. Let's go back to our formula. It says sine of 2 parentheses time minus 2s. Okay. So we go 2 parentheses. Okay, very good. Time hang in there. Minus 2 seconds. Let me see for a second here. Okay, so right there, see that? Less than 4 seconds. 6 inch plus 6 inch times sine of parentheses mechanism time minus 2s. We close the parentheses. Okay, so let's go back here. If there's a mismatch in parentheses and things like that, we're going to get it anyway. So this time 360 DEG divided by 1s. And yep, so let's check it out. As I said, if there are parentheses mismatching and things like that, it's going to pop up. Okay. As a matter of fact, we can check that right now. Let's do that. Syntax. Yep, no problem. And finally, else the distance equal to 6 inches 6 inches times parentheses time. Actually, there's something missing here. 6 inches plus. Now notice that here we have 6 inches plus 8 inch over 6 seconds. Okay, so let me write it like that. Plus parentheses 8 inches divided by what was that? Divided by 6 seconds. Divided by 6 seconds, and then times. Don't forget to include the shift minus. I believe that is 4. Let me see now. Minus 4s. 4s. Close the parentheses. That's good. So let's check for syntax. Nothing, no syntax error. We say okay. So we have created a law here. If you want to change or a rule actually, you double click on it. If you want, you can go and make the appropriate changes. We're going to find out. Now, that's pretty much it. So we go simulation with laws. Okay. Activate sensor because I want to see whether I get that same graph. If I don't get this graph, I've made a mistake somewhere. Now, let's do it over, how many seconds is that? Over a total of 10 seconds. Very good. So just play it. Okay. See what happened? Let me rewind this thing one more time. Change this thing to a slower mode. Actually, hang in there. Let me make this thing 1,000 so it goes slower. Okay. And when I graph it, I better get that figure. Okay, so let's see now. Oops. Sorry, I have to activate this. I forgot to do that. Let me rewind it. I forgot to say yes here. Play it. This is the amplitude of 6 inches. You see that? Unless I made a mistake, it should give you that graph. Now we go and graph it. That's too slow. I should have made it instead of 1,000, maybe a bigger number or smaller number actually. Okay, you know what? Let me stop this thing, rewind, change this thing back to maybe 400, and now we play it. Maybe 400 is maybe too big too, but that's okay. Let's find out. When I say graphics, I should get that same graph that I had in the slides. This is also going too slow. So let me rewind this thing, change this thing to 80. Now play it. Okay. Now I'm going to graph it. I should be getting this curve. Good. Graphics. There we go. Okay. This is all right, except that I should have cleared the history. Okay, let me close this. Try it again. Rewind. Clear the history. Because otherwise it shows me all the other stuff that I've done too. So let's run it. Graph it. There we go. This is that. All right, so that's fine. So let me go ahead and do my second problem. The second problem is these two blocks, a green one and a blue one, and they're moving according to these rules, and because these breakpoints are different, what I will do is I will make two rules, one for the blue one for the green one. So I'm going to have this kind of a C statement in the green block, and then where's the other one? This for the blue block. So let me go ahead and do that. Total 20 inches, 20 inches, 10 seconds. Okay, let's go ahead and do that. We're done with this. So we say, okay, let me close that. Let's start all over. So let's start with the product file. Let's do the track first. Insert a new part in there, and this is going to be our track. Right click properties, track, and track. Okay, let's make it. Let's go here, double click on that plane. I will sketch my rectangle, which looks like that, and it's going to be padded by 20 inches. Make it 20, maybe 22 inches. Okay, and then I'm going to insert the blue block. Insert a new part. I'll call it blue block. Blue block. And blue block. Blue block. Okay, let's go make it. On that vertical plane, I will sketch the rectangle like that. Exit. Add it by 1 inch. 0.787, no problem. Let me change the color here to right click properties. On the graphics, I'm going to change that thing to blue one. Okay, very good. And then I'm going to do the we're going to do the green one. So double click on the top, insert a new part. No, call this thing properties green block. Green block. Do a copy and paste here. Copy, paste. Say okay. Let's go make it. On that vertical plane, I will sketch. Okay. So another rectangle, like so. Exit. Pad it. Fine. I'm going to change the color to green. Right click properties. On the graphics, change it to green. I'll make it like that. Good. And now we're going to go and create our constraints. So I'll go to assembly design, anchor the track. Okay. And then we do the prismatic joint, basically the constraints for prismatic joint for the blue one. So coincidence between this plane and this plane, and coincidence between this edge and that edge. Very good. I do the same thing on this side. Coincidence between this plane and that plane, and coincidence between this edge and this edge. Very good. Okay, so now we're going to make two rules. By the way, let's go ahead actually create our joints. So you go to digital markup, DMU kinematics, get the magic wand out. New mechanism, mechanism 1, auto create. There's going to be two joints, and the joints are prismatic. Two prismatic joint. You can see that. Double click on this. Make it length driven, except that I want it to go in the other direction. Good. Double click on this fellow. Also make it length driven. And one second, oops, I wanted to change the direction of the motion here. Click on the arrow so that it goes also in the right direction. And now we're going to create our rules. So we go to start, knowledgeware, knowledge advisor. Let's start with the first one. I'll call it blue rule 1. We say okay. And we basically have to follow this, okay? So if time is less than 3, distance is equal to 0. So let's go here. If let me click on my mechanism so that I get the commands here. Now that one, okay, question which one is which? Okay, this one is for the blue one. Yeah, so that's I should have renamed these things, but anyway, this is for the blue one, I'm sure. Sorry, if time, not mechanism, if time is less than 3 seconds. Let's make sure I use the right thing. 3 seconds, yeah. Distance equal to 0. So this is for the blue one, except that it's on the next line. This is equal to 0 inches. Else if time is less than, let's go back here. That is less than 5 seconds. 5 seconds. Enter. So this distance will become equal to, of course, it was 0, but it wouldn't matter. I don't have to write it, but I will. So the velocity here is going to be 2.5 inch per second. 2.5 inch underscore s times parentheses time minus, don't forget the shift, and the shift is 3, right? Minus 3 seconds. Okay, enter. Okay, what's the next one? Then if it's less than 9, else if time is less than 9, it's going to sit at that distance of 5 inches. Okay, so we see now. Else if time is less than 9 seconds, distance is equal to let's see now, 5 inches plus oh, that's 5 inches, right? It's 5 inches. That's all. Else, enter. Let's do that here. This last part, if else is velocity 15 inch per second, you can see that. Okay, and then the shift is t minus 9. So it's going to be, yeah, that fellow is equal to 5 inches plus 15 inch underscore s times time minus 9 seconds. Hopefully I haven't made any syntax mistakes here, but we'll find out. Let's see now. It looks good. Okay, very good. And let's check for syntax error right here. Okay, there is a problem right there. Oh, I forgot the equal to right there. And it should be okay now. Good. So this is the blue one, and then I make another one for the green one. So rule, I'm going to call it green block, basically. Okay, you say okay. So all we have to do is basically put this stuff in it. Okay, so if less than 2.5 inch per second. So if here, if time is less than 2 seconds, distance, this is the command for the blue one, for the green one. Double click, equal to the 2.5 inch underscore s times time. Okay. Else, what is it that we have here? Else if time is less than 5. Yep. Else if time is less than 5 seconds, the distance is going to stay at 5 inches. 5 inches. I forgot the equal sign here. Okay. And finally, else. Okay. Distance is equal, oops, right here. Distance is equal to 5 inches. Oops, where is it? Equal to 5 inches plus. Now let's see what the speed is here. The speed is 3 inch per second. Okay. Plus 3 inch underscore s times parentheses time minus, and that shift in time is 5 seconds. 5 seconds. 5 seconds. All right, let's check for any syntax errors. Looks good. You say okay. And what we're going to do is now we're going to go back to the digital mockup, review kinematics, simulation with laws, activate sensors, both of them yes. Move this thing out of the way. and play it over a 10-second interval, what we should get is these graphs. Otherwise, there's a mistake somewhere. So let's go here. Okay. On the graph, there we are. This blue one, this green one, see that? This green one is, let's see now, one of them is this, and the other one, the yellow one, is this graph. So let's check it out. Yeah, you can see that 0, and then it goes up, and then there we are. So I have generated this information, which means that there was no mistake in my code. Now, once you do that, then of course, if you want, you can plot the velocity, acceleration, etc., which I'm not going to do. You're responsible for that anyway, and you know it well in and out. Okay, good folks. So this is it.